Consider two random variables, x and y, with a joint probability mass function given below. So here's the table. For example, the probability of x equals 1, y equals 4 is 1 over 24. We have 4 questions here to calculate the probability of this and find the marginal probability mass function for x and y, and calculate the conditional probability and check whether x and y are independent. Let's start with the A. Probability x is less than or equal to 2, y is less than or equal to 4. So let's look at the x. X can take 3 values, 1, 2, 3. X is less than 1, less than or equal to 2, which means that x can take a value 1 and 2. Y is less than or equal to 4, and y has 3 values here, so which y is less than or equal to 4 means that y can take a value 2 and 4. So x 1 and 2, y 2 and 4. So we can write this out. So this is equal to probability x takes 1. Let's say y is equal to 2 plus probability x equals 1. Y can take value 4. And now x can take value 2 and y take value 2 plus probability x takes value 2 and y takes value 4. So basically, it's the summation of these 4 numbers. So 1 over 12, 1 over 24, 1 over 6, and 1 over 12. So basically, the range of x and y that satisfy this condition is this square, right? These 4 values. Let's calculate that. So it's 1 over 12 plus 1 over 24 plus 1 over 6 plus 1 over 12, and this is equal to 3 over 8. So the first question. B, let's calculate the marginal PMF of x and y. Let's start with x. Let's calculate the probability of x equals 1. So as you can see here, x can take 3 values. We have to calculate the probability of x equals 1, 2, and 3. So let's first calculate x equals 1. So the probability of this is equal to x equals 1. And y, when x is equal to 1, y can take 3 values, right? So we have to write them all out. So x is equal to 1, y equals 2, plus probability x equals 1, y equals 4, plus probability x equals 1, y equals 5. So basically, it's this whole line, right? So these are 3 numbers. So when x is equal to 1, y can take 3 values, 2, 4, and 5. So the probability that x equals 1 is the summation of these 3 numbers. So this is equal to 1 over 6. Okay, I won't repeat all the the calculation, but basically we can calculate the probability PMF for x is it can take 3 values. So when x equals 1, we just calculate it. It's 1 over 6. When x equals 2, it's basically the summation of these 3 numbers. 1 over 6, 1 over 12, and 1 over 8. This is the second line. So this is equal to 3 over 8. When x equals 3, it's 11 over 24. And similarly, we can calculate the PMF of y. So this is equal to 1 over 2, y equals 2, 1 over 4, y equals 4, 1 over 4, y equals 5. Let's take a look. So basically, when you calculate the probability of y equals 2, so x can take 3 values. So the probability of y equals 2 is the summation of these 3 numbers, 1 over 12, 1 over 6, and 1 over 4. 1 over 4 is basically the first column, so which is 1 over 2. And similarly, the probability of y equals 4 is the summation of the second column, which is 1 over 4. And probability y equals 5 is the summation of the third column. So let's look at C. So these are the marginal probability of mass functions for x and y. So let's look at the question number C. So C is probability y equals 2, x equals 1. So this is probability, conditional probability. So based on the formula for conditional probability, so this is equal to probability y equals 2, x equals 1, divided up by probability x equals 1. So let's take a look. So this is equal to y equals 2, x equals 1 is here. So y equals 2, x equals 1. So this is 1 over 12 here, 1 over 12. So we will write 1 over 12 here. And probability, the denominator is the probability x equals 1. So we just calculated the probability of that x is equal to 1 is 1 over 6. So it's here, 1 over 6. So this is equal to, hold on, 1.5. So let's look at the question number D. The question number D is whether x and y are independent. So to prove that x and y are independent, we have to prove that for any possible value for x and y, probability x equals x, probability y equals y is equal to probability x equals x times probability y equals y. So this has to be true for every pair of x and y. But we can see that this is actually not true for some select values. For example, the probability of x equals 2, y equals 2 is equal to x is 2, probability of x equal to 2, y is equal to 2 is 1 over 6 here, right? Based on this table, x is equal to 2, y is equal to 2, the probability is 1 over 6. But the probability of x equals 2 times probability y equals 2 is equal to, here, the probability of x equal to 2 is 3 over 8. The probability of y is equal to 2 is 1/2. So this is a 3 over 16. And you can see these are not equal. So this probability, 1 over 6, which is the probability of x equals 2 and y equals 2. And the multiplication of these two probability is 3 over 16. They're not equal. So they are not independent. Thank you for watching.